to go ahead and get us started here. Let me grab my notes so I know what I'm doing. Welcome to my little panel that I've been working on for a little bit now, New Tech in Fursuit Making. My name's Rain. I run the Fuzz Factory. These are a couple of my suits that were at FC this last year. I started Fursuit Making 2011 was my first suit I ever made. I was going to Anthrocon and I found out that if you wore a fursuit, you could get a special fursuit badge. And I was like, that sounds cool. How hard can that be? And now here I am like 20 or 15, 14 years later, and I've made about 130 of them, 130 fursuits. I started out, like, I think my first commission was $450 for a partial. Now I charge a little bit more. But it's been a fun journey. I started out like a lot of other makers. How many people here have made a fursuit or fursuit parts before? Yeah, a good chunk of you. Excellent. Yeah, that's awesome. I started out like a lot of other people looking at matrices, tutorials, various tutorials, live journal things I could find. I also my background is actually in theater. I have a master's in technical theater. I used to design and build sets and actually taught college for that for a few years. And so I had a lot of experience with hands-on, but fursuits and theater sets are a bit different, a little bit different materials, but a lot of the ability to learn new things and try out new things and kind of fail along the process so that I get better the next time really works in the same way in fursuits. And the more you fail, the better you get in this process. I started out like a lot of other people with duct tape dummies and tape patterning. I don't know if anybody's done a duct tape dummy before. Yeah. Tape patterning to make heads and stuff like that. That's a super common way to do that. And as I kind of evolved and my craft evolved, I started to want to learn new things. And specifically around the pandemic, when we all got kind of locked in a little bit, I started to play around with some new technology. I got into VR chat. How many of you here like VR chat? Yeah. I was like, I really want to try to make my own models, and that was really hard. I failed my way through a couple that were okay, but I started to learn Blender, which is a piece of software that is free and difficult to use, but once you start to use it, you can find a lot of purposes for it, and I'll be talking about that more later. I also got my first 3D printer, a resin printer, a longer orange, just a little guy making resin prints. I used it for making 3D models of my like D&D minifigures because it was really great for that. I also used my partner's Ender 5 Pro. That was my first 3D printer that I was really using. Over time, I've invested some of my money made from my work into my own printers. Grew up with a bit bigger printers, better quality printers, and I'm going to be talking about those a little bit later. And I've learned a bunch of software, a bunch of different techniques, and I'm going to go through all of that today. The goal today is just to kind of like go through some of the stuff that I've made and how I kind of made it, to share some tricks and tips and starting off points, because some of the stuff can be a little bit daunting. 3D printing is kind of scary, modeling is scary, but these are all things I've made using 3D printing, 3D scanning, technology where I was using different type of methods to add electronics into certain things, stuff like that. So we're going to be going over a lot of those things today. So our basics in technology in 3D scanning, we'll start there. Using commercial scanners or cell phones to make it a little bit more approachable. Modern technology, most everybody has a cell phone, and most cell phones can do 3D scanning in some way. And that's pretty cool. I use programs like Nomad Sculpt and Blender. How many of you used Blender or Nomad Sculpt here? Yeah, a good chunk of you. Super powerful tools, pretty inexpensive as far as software goes. Blender is free to use. And you can do almost anything I'm doing today in Blender. And then I'm going to talk about 3D printers with a focus on what types of printers there are, what types of filaments there are, and how to use them, and like a little bit of like the do's and don'ts. Some things to think about when you're buying your own printer, if that's something you're interested in. And then patterning, how to make a fursuit. And we can use, like my iPad has some pretty great technology. I can actually pattern and create directly from my iPad to create patterns for clothing or fursuit parts. and kind of skip steps of needing to do the normal patterning that you might see in other in like traditional like duct tape patterning. Finally, I've got like a miscellaneous category. I've integrated LEDs. I've integrated moving parts into fursuits. I'm going to talk to you a little bit about how to get started with that. That alone could be a whole other panel or 8 because there's just so much technology available right now. But today we're just going to touch on it pretty briefly. All right, so first up, 3D scanning. Well, I'm going to be focusing kind of like how this presentation and the order in which I would make a suit. So one of the most important things to have when you're starting off is a starting area. So like scanning can be an incredibly powerful tool to go from a digital to real world by starting with an object in the real world and scanning it so you can work on top of it. I've worked a lot with scans of various parts, like you can see a croc that I scanned. This is I made a fursuit named Toft. He's a alpaca, and his feet are based on that croc. Yep, I scanned his croc. He sent me some crocs. I scanned them, and I 3D modeled over the top of them. In fact, I can show you that here. Let me see here. So there's the croc base. Look at that beautiful, fully rendered croc. This was scanned with my cellular telephone, done really easily. There's other software you can use or hardware. I have other ones that I use as well, but that one is one of the main things I use.
Is it hollow on the inside?
Not completely, but it gets back there pretty far. Really what I just need is the outside shape though, because then I can model a part on it. Here, let me find my like another example of that. But you can see here I've got like a foot, and if I remove some of the other layers, we have what was the original scan, right there. That was the original scan of this individual shoe that I pulled down so that it would be nice and easier and kind of smoothed it out. But you can see the front of the shoe there, and the top where the heel is and everything too. So super useful for that kind of stuff. Let's see here. So yeah. So a couple of somebody asked about like devices. There are commercially available devices. I use a Revo Pop 3D device. It was like $700. It's a little bit expensive, kind of fussy. The software's a little difficult, but there's a bunch of other new ones. Creality created a really new scanner recently that's been really highly rated. And I know that I got a couple friends that use Minico for like they do like car parts and do things for their house, and they scan stuff so they have exact models. But these scanners can be used to do things like scan your head so you can build a fursuit base around that. Scan shoes, scan body parts. And I'm going to go into more deeply later a full body scan I did of myself, and then I built a project completely off of that. But a scanner can be really useful. And then for iPhones and Android options, there's Polycam, which has a paid 3D, paid level, and then a free level. And then 3D Scanner is an iPhone exclusive app, I believe, but it uses the LiDAR in an iPhone, which can be pretty useful for this. And WiDAR is another one that I found that is pretty highly recommended. So those are a few options available for you as far as scanning. Some of the important things to remember when you're scanning is some tricks. Scanning never likes shiny surfaces, so you want to make sure your surfaces are as smooth as possible. In fact, they sell a anti-shine spray, a scanning spray. It's kind of like in a hairspray bottle. You can spray onto something and it just kind of degrades over time, but it makes it so that the lasers in a scanner or the camera can see that shape a little bit better. I've also used just like gray spray paint if it's something that doesn't matter that much. For like shoes, I'll spray paint it gray and you can use that really well. Scanners tend to hate fur. So and hair as well. So if you're going to scan your own head, I'd recommend going like having like a balaclava on for that. Let me see here. Get that back. So I'll show you a personal project here of my. This is my head. That's me. Hanging out there. That always feels weird to see yourself scanned like that. But there I am. It's like my death shroud. It's kind of weird. But what's great about this is it gives me a perfectly scaled model of my head. I know that when I work in this in other software, I'm going to be able to use, it's going to be the right size to begin with. One of the difficulties when you're working with digital models is not having scale to begin with. Blender and Nomad Sculpt, when you start, doesn't have scale. It has units, but those units don't really correspond to anything until you get them something in scale to work with. So scanning, you want to make sure, some of the scanning hardware tends to be better at keeping that scale perfect. It'll scan one-to-one, exactly the right shapes. Some of the software on your phone might need some help with scanning things. So like I recommend like taking a measurement from your ear point to your ear point so that when you load it into Blender or other software you're going to be using, you can scale it and get it the exact right size. Because if you built like a fursuit head and it's about 10% too small for your face, and you're going to spend 40 hours printing something like that, it's going to be a big disappointment when it's just a little bit uncomfortable, it's a little bit wrong. So getting that scale is one of the most important things when you're doing 3D scanning. So I highly recommend taking your time in this step in the process just to get that scan right and set up for success later. Up next, 3D modeling. So this is a head I did recently. His name's Miles. He was a meerkat. He's a local friend of mine, so I was able to get an actual 3D scan of his head and make this head as small as possible. The goal was just to be incredibly form-fitting. He wanted to be able to wear it as a partial and it not kind of feel that toony shape. And I personally love having fursuit heads that are big and kind of toony. That's kind of my background. But it's fun in 3D printing is I can really scale that to exactly the right shape. There is a bunch of software to use. There's a bunch of software you can use for sculpting, though some of it gets pretty pricey. Blender is the free option that's the most common. There are tons of YouTube videos on how to get started in it. It's a little tricky to get used to at first, but with more and more practice, you start to learn the flow in which the application wants you to work. And once you get used to it, you can do a lot of stuff in Blender that it's harder to do in other software programs. Things like fixing geometry is something that happens a lot in Nomad Sculpt. It'll put little tiny holes in your geometry, and computers don't like, the 3D printers especially don't like those little holes in the geometry. So being able to then go back into Blender and be like, fix this, because somebody has created it, being a free software program, open source, people have just made applications that are like, fix this model for 3D printing, and it just does it. And you can get around some of the difficulties you might find in other programs. But Blender's pretty technical. It can be kind of difficult. My personal favorite software is Nomad Sculpt. It's an iPad piece of software. They keep talking about bringing it to other like PC, stuff like that. But it's a little bit difficult. Yeah?
It's also on Android.
Is it on Android?
Yeah, it's one fold. I have it right.
Oh, sweet. It's on Android as well. Cool. Yeah, and I love that program. It is my go-to program. I feel it's really intuitive. It's really powerful. You can do a lot with it. For my purposes, since I'm not like coloring anything, I'm working just to get the shapes right, and then I'll print it. It works super good. And I've seen a lot of people do some great stuff with it. Like I find that like just practicing with it though is the best thing you can do is just like find a thing you like and make a model of it, because that can work really well and make like something fun for yourself. I've been doing a lot of like practice with that program, and yeah, it's very artistic focused. Like if you're used to a lot of other art programs, this will kind of feel natural. Then there's ZBrush, which is like the high-end version. It's also the really expensive version, and Maya, which is also expensive.
There is a free version of ZBrush for iPad. It's like they've cut down some of the features and options, but it's actually pretty good.
Yeah. Okay. Cool. So there is a free version of ZBrush for the iPad, but it's a little bit limited. My personal favorite is still Nomad, just because it's $20. $20 and you're good. There's an add-on for it called Quad Remesher, which is my biggest recommendation is if you want to get a Nomad Sculpt, buy the Quad Remesher add-on. It is a piece of software that basically when you're messing around with the geometry, you'll change the quads, which is basically the points in space in the application. Actually, show is better than tell, right? So if you look at my face here, if I go into wire mesh, you can see all the points in space And these are all quads. They're 4-sided pieces. Quad remesher allows you to simplify your geometry. So if I wanted to go like that, and then I wanted to half the amount of quads, the amount of faces on this model, I can just click that half button and it will simplify it. And you can see that the amount of quads decreased, but it kept the regular shape of pretty much everything on there. So it's really helpful when you're you're doing something aggressive with your work. You can hit that button, the thing does a bunch of math, and it makes it pretty for you and easier to print. So something super, super nice to have, simple, my favorite add-on by far. And it's actually an add-on that's available. The same person made it for ZBrush originally as part of their big paid thing, and then also makes it as an add-on for Blender, but it's $120 on Blender. Nomad Sculpt, it's $15. So it's a pretty good deal as far as all that goes.
What app is that on your iPad?
Nomad Sculpt.
Oh.
Yep. That's the one I use. I love it. I like with a pencil and everything. It's just super intuitive to me. It feels really nice. There's a lot of really neat features. I plan on doing one of my goals for the summer is I do YouTube videos. I've done a couple on TPU, which I'm going to be talking about a little bit. But I really want to do like a tutorial on how to make a fursuit part in Nomad Sculpt. That's going to be a big summer goal for me. So hopefully I'll have that done later this year. And then finally, there's technical software. AutoCAD, SolidWorks, and Shaper 3D are 3 of them. Shaper 3D is a good iPad version, iPad software. But if you're doing something that like requires like specific shapes, rounds, squares, something like that, where it's like a little bit more engineering focused, those can be pretty useful in helping you out. And I also use it for certain things like I made this guy, his name is Vortex. He's a character from Hell of a Boss. His shoulder spikes are printed in TPU, so they're soft. But I modeled those real quick in Shaper 3D because it was just a lot easier to like make an engineering style model that's just like point. These angles are nice and even. There's a built-in bolt mechanism, so I can literally just screw the spike onto his jacket, and it's just done. It's on there. But that's like an engineering side of the same sort of coin. So that's some of the 3D modeling software. Yep.
I just want to bring up for anyone who has VR headsets, they actually have 3D modeling in VR.
Yeah.
Like that more hands-on.
Cool.
I think it's a
Sketchfab?
Yes, there's Sketchfab, Shape Labs, and Gravity something.
Gravity Sketch.
Gravity Sketch.
Cool. Yeah. So there's some options in VR stuff as well, which could be good to look into.
There's also a plugin for Blender that'll let you see some.
Oh, that's pretty cool. Yeah, that's awesome. Yeah, so there's a lot of options. Blender is one of my favorites just because it's open source. Like, there's a lot of people making cool stuff all the time that may just make your life a lot easier when you're doing a model piece, whatever. So next we're going to talk about 3D printing. This is one of my favorite things. I could talk about for hours about this. I absolutely love 3D printing. It feels like the most Star Trek thing that's happened to like our generation is like, I had an idea. I needed this thing to hold my cell phone in a specific way. 6 hours later, I have that thing. Like, it's just kind of magic, and I absolutely love it. I'm going to talk about the 3 kind of major types today, but we're only going to go in deep to 2. The first one is stereolithography, which is SLA. This is resin type printing. It's the oldest type of 3D printing. It actually was invented in the 80s, I believe. But it uses a liquid resin that has a reactivity to light, and that light hardens the resin, and then it slowly makes more and more layers until it comes up with a 3-dimensional object. The second one is selective laser sintering, SLS, which is prohibitively expensive. I just want to mention it here because it's one of the 3 major types of 3D printing. But it basically uses a laser to melt nylon together in layer after layer of a bed of nylon dust until you get a part. And it's fascinating. I'll talk a little bit more about that soon. But it's also very impractical as far as how much space it takes and how expensive it is. And finally is FDM, or fused deposition modeling. That is the most common. When we think of 3D printing, that's what most people think of. It's also called extrusion style printing. It's basically, you take plastic, you heat it up through a tiny nozzle, and you layer it until you get a shape. And you keep on layering and keep on layering, and then you eventually get whatever it is you're wanting. That's the most common type. It's what we'll talk about last but it's the one I use the most. I have 2 printers just for this purpose because I love it. I use it all the time and stuff that's like artistic, but I also use it for fun. I want to make a joke for my friend. I can make a thing real quick, and it's a lot of fun to make that work. So SLA printing, we'll start with that one. SLA is resin printing. It uses one material, that's the liquid resin. Now, there are, like with some of the other printing types, there are a bunch of different types of liquid resin you can use. I tend to just use pretty simple, like solid color resins because everything I do, I tend to paint. But you can get translucent resins. You can do, this is a great thing to make like minifigs with because you can get all sorts of different colors or like reflectivities in the resins. Basically, this works. You can see that this is the machine this is the machine that I own. It basically has a big aluminum bed, which is at the top, and it's on a screw drive, which moves it up and down. And at the base there is a reservoir with liquid resin in it. And directly underneath that liquid resin vat is a tiny, basically TV screen that only has one color, and that's ultraviolet. There's a bunch of pixels on it, and it sits underneath the clear bottom of the reservoir. And what happens is the bed goes down to the bottom, lifts up a tiny amount. The light shines on it for a few seconds in whatever shape it's got the slicing software has pre-described. And then it sits there for a second, lifts up, pulls that new shape off of the bottom of the plate because it kind of sticks a little bit, pulls that off of the bottom plate, moves it down just a fraction higher than it was before. Light, lift, down, light, lift, down. You know, a couple thousand times, depending on the size of the model. These printers can take a long time to work, but the end result is incredibly high detail models that are really great to work with because they're mechanically very well bonded together, and you're able to do a lot of cool stuff with it. Now, it's one of my favorite things about it is it's really easy to sand. It's like, because it's just particles absorbed together, it's kind of like nice to sand. They're very easy to deal with. If you ever work with other resins, it's in that same vein. You can just sand it with normal sandpaper, polish it up. You can actually buff it and make it super shiny. It is really incredible material to use, but it is a little bit dangerous because resin is toxic. This stuff is not good to be breathing in. It's not good to be touching on your skin. You're basically dipping it in and out of a vat of itself. You can see it's covered. That cover is yellow because it's getting rid of the UV light, not letting UV light in, because UV light would actually harden the vat. As it's going up and down, it's covering everything in resin. And the cleaning process is a big pain in the butt because you take it out, you have to have gloves on, mask on, ventilated area, break the part off of the bed, stick it in a vat of alcohol, let that spin for a while, clean off all of the resin because the resin, the liquid resin will decay in the alcohol. And then once that's done, you have to then set it in another little container and let it get hit by UV light for a while, and that finishes the hardening process. And all the while, you need to make sure this place is ventilated and you have your mask on because this stuff is like, it's pretty toxic. They make some non-toxic versions that are pretty new. I'd like to try them, but like, I wouldn't necessarily want to use the, like when I'm doing this, I have a mask on that covers my eyes as well, because you just want to make sure you're really safe with this stuff. But this stuff is really cool, and it can make cool different parts. In fact, in this suit here, his nose and his teeth are made out of resin. His nose is actually covered in vinyl car wrap to get a texture like that, but because it was resin, it's super light, it's super smooth. I didn't have to sand it much. The teeth as well were super smooth. I just hit them with some spray paint and a gloss coat, and they look great. Like relatively easy to work with as far as materials go. I wouldn't ever have the resin in parts that touch my body. Because the material is toxic, you want to make sure there's some sort of barrier. You can paint it and you can seal it. That will be pretty good, but you just want to make sure you're pretty safe with resin because resin is the most toxic of what I'll be talking about that I use regularly. So just make sure, if you do use it, read the safety instructions because they are important. All right, anything else? I think that's pretty much it on the SLA printing. The next one is SLS. This one's super cool. It basically, how this works is, this one you can see there's 3 machines in this because it kind of, you kind of need a lot of machinery to make it work. What's happening in an SLS printer is there is a reservoir of powdered nylon, and there's a machine that takes there's a build plate basically, there's a machine that layers on a little bit of that powdered nylon, and then a laser hits it in whatever shape it's supposed to be, and then it drops down a little bit, and the machine layers on a little bit more of the nylon powder, and it lasers it, and it lowers it, and it lasers it, and it keeps doing that. So it's, in a way, very similar to the previous method, except for, so in the previous one, you could see the supports, those little sticks, basically vertical sticks going from the build plate at the top to the model. The SLS printing doesn't need that because the powdered nylon that is not being lasered will support the material as it's being printed. So it's kind of cool. It is like $40,000 to start with one of these machines. So not really anything I'm gonna ever use, but it's important to talk about because I think it's really cool. The parts are super strong. They would be stronger than anything I would be making in any of these other methods. But like I said, I'm showing this to you because I think it's important to know that it's out there as a 3D printing nerd, but it's just impossible to use, at least for me, unless somebody wants to donate like 50 grand. So, but my favorite type of printing, the type of printing that's most common, is the FDM style printing. This is the printing that we think of most for like most of us, fusion deposition modeling. It is basically what's happening is, like I think I said this already, is a filament is being put through these tubes, and it goes to the print head, which is on a machine that moves it around. And inside that is a heating element, and that heating element heats up the filament to 240 degrees Celsius or somewhere about, depending on what type of filament you're using, and pushes it down onto a build plate, and layer after layer builds a structure. What's really cool about this is this has a ton of different varieties of filaments. There's a lot of ways to use it, and I have had a lot of fun finding the different materials, playing around with it. In fact, my first 2 YouTube videos that I did, which I only have like 2, they were both just about one type of filament because I thought it was so cool. And I honestly think it's like one of the coolest things in fursuit making that exists right now. And I'll talk about that in just a second. But there's 3 types of filaments that we primarily use. PLA, which is like the plastic type that we normally think about. TPU, which is a flexible foam-like, rubber-like filament. And then PETG, which is a little bit stronger version. It's actually quite robust. And I'll use different ones of these different ways for different parts because they all kind of work together to make things. There's 2 printers here. These are actually the 2 printers I own. One is a Carbon X1. What's really fascinating about 3D printing, even in the last 5 years, is it has become so much easier. That first printer I talked about, you have to like level the bed manually, and you have to put a piece of paper underneath it and make sure each corner was the right height. And it was so fussy. And then you'd spend like 14 hours on a print. You'd come in the next day and it'd be spaghetti everywhere. It's just a mess of like filament that never bonded to anything. And you just you just wasted $15 of filament. That's not my favorite. And some of the newer printers there's a lot of different versions of printers that are in the same vein of this. Starting at around like $150, $200, there's some really small, inexpensive ones, going up to multiple thousands depending on what you're looking for. The one on the right is about $1,500, and it supports like multi-filament use. It can actually change its filaments mid-print. So if you want to have one part blue and one part green, it can do that automatically as it's printing. Yeah.
Can it change between filament types?
Yes, it can. But yeah, and I'll go into that too because there's definitely weirdness with filaments. Yeah.
So, as a person who's never had any experience with 3D printing, how easy is it to make? So I do some 3D modeling, how easy is it to just transfer that into 3D printing?
It's super easy. And I'll talk a little bit about software. In fact, I could talk about that now because now that we've talked about the different types of printers, we can talk about slicing. Slicing is something that we use in 3D printing. Basically, it is taking a model and being like, what I want to do, I'll use this as an example. This is a test piece I made for testing TPU types. What I'm going to do is, I want this shape. There's little strugglies here. I'll talk about that in a minute. I want this shape. And you send it into your slicing software. There's a bunch of different versions. Every printer has its company has its own slicing software. There's this different slicing software for resin versus extrusion type. But slicing basically takes this model in 3D and it cuts it in layers. Ding, ding, ding. And then from that, it figures out, okay, well, if this is the layer here, I have to make this shape. And then it makes that shape in the software. And then it creates something called G-code, which is a piece of a bunch of commands that your printer takes and says, okay, I need to go here, and then I turn on, and I started pushing out my filament, and I go here and here and here and here and do this, and it just does it. It's like crazy. You can actually look at some of them actually have like a live viewing of G-code as they're printing. You can see it just go barreling down the list of what it's been programmed to do. But the slicing software just does that for us. I've used primarily Bamboo's slicing software and the Prusa slicing software, and they're both pretty easy to use, pretty intuitive. And the printers themselves get rid of the need to do bed leveling and flow testing. They calibrate themselves. The Bamboo Lab has a laser in it that it checks its print, it checks how good the flow is doing, and it'll check its first layer. That one even has a camera in it that detects if it's messing up, and it will message you and be like, it literally just messages my phone, and it's like, I paused because I think there's spaghetti, and you have to be like, you can look on the app and see if it's actually bad or not, and continue it or not. So these new ones, even old prints, if you were going to make 15 of the same thing on a bed, right? If you had one mistake, it would ruin everything. You kind of needed to start over. The new ones, you can be like, this one didn't work. Just stop printing that one. And it will know that, and it'll just continue with the other 14 of them. And it's just mind-blowing when I realized, it's so much easier, so much less wasted material that way. But yeah, slicing software usually comes with everything. Every one of these has slicing software. It takes a little bit to get used to. You always want to start with your bench sheet, it's your benchmark print, and see how it works. And then play around. I recommend, if you're new to printing, play around with some free models. There is Maker World, and Prusa's got, what's the Prusa one? Printables. There's tons of free stuff. So I use a lot of I need pencil holders. I'll just go and find a set of them on one of these websites for free and just print it. Great way to get started with just printing basics and then work your way up. So yeah, software is important. But back to the FDM printing. Filaments, the only weirdness with them is filaments dry. And filaments, actually the other way around, filaments get wet. They absorb humidity in the air and they get wet, and that makes them brittle. I've seen before pictures of somebody that I had this filament in a box opened for 5 years, and it just cracked little pieces that are 4 inches long, and it's all destroyed because it wasn't kept in a good environment for it. It ships with desiccant in it to keep that humidity down. I've gotten to the point now where I bought a decent drying system. So every time I print, I just throw overnight. If I know I'm going to be printing the next day, I throw my filament into dryer overnight and just make sure it's dry. Because that has solved so many problems where there's just a weird little defect somewhere, or things didn't quite stick to the bed right, or it got clogged in a weird way. So yeah, drying is huge for that. Yeah.
You can also be successful using your hotbed to heat it up.
Yeah.
And also, you can also leave it in a container with a lot of desiccant for a week straight.
Yep. But having a inexpensive dryer they sell a lot on Amazon is pretty great. I have drying boxes that I use because I the TPU specifically is a nightmare. It is you leave it out overnight once, and the next day it will not print the same. Back to back, 2 days, it will be, one will be beautiful, and then a day later, because you left it out, it will be like none of the pieces stick together. It's stringier. It's gross. So it's important to remember, like, it's just want to keep an eye on your filament, making sure that it's dry. So PLA, we got about 25 minutes, so I'm going to try to go through this pretty quick. PLA is the most common type of filament. It comes in all sorts of cool stuff. I saw a bunch of things down in the dealer's den that were made out of PLA. You know, the super shiny 3D prints, and the ones that are like translucent. And I even made I made these. This is my business logo, but there's a filament. The darker filament's actually UV reactive, so it turns purple in the sunlight. And you know, you can do all sorts of cool stuff with these types of filaments. One of my absolute favorite filaments to use in fursuit making is a filament called Cosplay. Cospla, and it is made by Polymaker. It is a sandable filament. It's really good for making props, for making pieces. This guy has a bunch of it in him, and I just use it all over the place because it's really, I get it in like 5 kilogram bulk rolls. It's super useful. It's super easy to print with. It's the least fussy. It's basically like the bread and butter of 3D printing. Yeah.
Can you give us that brand name one more time?
Polymaker. And then, so like if I'm doing rapid prototyping, sometimes like when I make a fursuit, I'll like make the eye out of PLA. I'll make a shape for the eye, and then I'll cut it out of another plastic. But this way, I know that the shape is going to be perfect. I can use that shape to transfer to another piece of plastic. You can also use it for like making vacuum form molds and stuff like that too. So there's some weird options there. But it is basically the bread and butter of 3D printing. Next is TPU. This is the Vortex suit actually has like a drop crotch piece that helps it like look, because his torso is super long. So this is that drop crotch piece. This is the character's butt. But what's really cool is this is all 3D printed. That whole suit is 3D printed from the bottom, from about here down. Every part, the thighs, the calves, the feet, everything is TPU. And you can see that, you know, TPU it's flexible. It's fairly soft. It can be a little bit uncomfortable on the skin if you let that happen. So I recommend covering it with like a piece of felt or something more comfortable. Neoprene is also another common one. But super easy to work with, and I love it because it is super flexible. And like you can see that head there has 2 different versions of it. And I have that kind of represented here. When I print with TPU, you might see these weird shapes. You might have seen these weird shapes with other TPU prints online. You might have seen somebody saying, I 3D printed a head. So this is called a gyroid infill. And basically what you're doing is it's a shape that the slicer figures out automatically. You say how much of a percent of the body you want infilled. So it's going to be like a percentage of the infill. It's going to change. So like this is actually a perfect example. This is like a 35% infill where like it's pretty dense. You can actually, I'll pass these around. You can feel that. That's a 35% infill versus a 10% infill where it's like super soft and squishy. And these are like a bunch, and then the halfway between is like, this is about, I think this is a 20% infill. So you can feel there the difference between the materials. The less infill you have when you're doing a gyroid infill, the softer the material becomes. And not only that, there are also like multiple types of material. So like that one I'm passing around is a very specialized TPU called Variassure. It actually is a foaming filament. Depending on the temperature you extrude it out of the end, it becomes softer. So these two pieces are the exact same filament. This is the colder version, and this is the warmer version. And you can feel, and you compare them, you can feel one is softer, one is colder. And the only thing I changed on these two is the temperature of the extrusion. But these are like the super high end. You don't see those a lot in most fursuit making because those are about $70 for 0.7 kilograms, and they come from Germany. So they are also imported, a little bit difficult. Versus the this is a Bamboo Labs TPU, high flow. It prints really fast as opposed to that, which is really slow to print with. But you can see there's 2 more that have different densities, so you can feel the difference between different TPUs. Yeah.
Side note too, like you also print without walls on the modeling
Yep.
that you put in the slicer.
Yep.
Otherwise, it kind of feels like it's like an extra layer of strength. If
Yeah.
you just do dry run, it will still look like that. You don't need the walls.
Yeah, that's what I'm about to say. This is filled with no walls. There's no external surface. So there's two different things you can see there. The gray has walls around it. So I wanted a smoother surface for the nose, obviously, because I want it to be soft and round. And the material isn't fur there. It was minky fabric. So I wanted to make sure that it was a good fit for that. And that when I use the exterior and a lot less infill versus the head where I use a little bit more infill and only use the gyroid and turned off all the walls and top layers too. Yeah.
So you mentioned earlier about like storage with the filaments. For after the print is done, do we still have to take the same precautions?
Of the printed part?
Yes.
No. So once you're done, it's a lot more stable. It's just because it's bonded the pieces together, as opposed to when it's on the roll, it's in tension, right? Especially the TPU, or the PLA, it's in tension because it's bent around the cylinder. So that's where it'll start to break apart. The PLA does degrade a little bit, but the problem is more when you're putting it with a lot of humidity through the extruder. It's popping, it's bubbling, that water is boiling basically, and you want to get rid of that as a problem. Once it's printed, not really much of an issue. It stays pretty stable after that point. Yeah.
How do you get good first layer adhesion if there's no solid walls?
So that's another good question. So if I go back to my my printers, so the Bamboo Lab, not good at 3D printing in TPU. Switching filaments is really hard for TPU because it's really soft. It's like wet spaghetti trying to be pushed through the tubes. It doesn't like it very much. So you want to avoid using you can directly feed into the back of the Bamboo one, the one on the left there. The one on the right is I have the two-headed version of that one, and that one I'll use a mixture of two filaments because that one actually switches between tool heads, so you can have two different filaments loaded at the same time, and it never unloads and puts it back in. So that means that I can use like a PLA, a really inexpensive $10 a kilogram roll as like base layers and adhere to that. And then the TPU has had no problem with adhering to those kind of things. Sometimes if I am having issues, I'll have a bottom layer and that's it. You can kind of see here, there's a little bit of a bottom layer there. And so that'll give me something to adhere to, but I won't have the top layers. And then I'll slice it in a way that I know that won't be an issue as far as long-term use. Yeah.
When you print like digi padding or like what you're holding in your hand, do you have to then polyfill it with like stuffing or something, or do you just sell it?
This does pretty good as is. You can make a padding pocket for it, like you would with polyfill, and just have it sitting in there. Or you can do something like a Velcro attachment, because Velcro can detach to this pretty well with a little piece of Velcro and hot glue, and then it'll kind of lock it into place. And then this can also be like vacuum packed pretty well too, so you can travel with it a little easier. The entire torso I vacuum packed to bring it down.
So you can print it like with a thick enough wall to hold up, collapse on itself.
Yeah. So, and this is printed with about 3/4 of an inch with a 15% infill, and so it's pretty rigid still, but it has enough flex as I'm moving around that it moves with me too. So.
Okay.
Yeah.
Any recommendations for adhesives to use or avoid whenever working with that material?
As far as like gluing material to it,
Yes.
I have had really good luck with hot glue. When I'm gluing it to itself, I use E6000. That is my favorite, my go-to adhesive for bonding TPU to TPU. And when I'm putting fur into it, the hot glue tends to work just fine because it's getting into the pores. It's a little bit more difficult when the material is smooth, when you're doing an external layer. But because it's porous, it's just like the glue gets in there and like bonds. It bonds stronger than it does to foam. Foam
I
first.
didn't know if you had any accidents using like melting the plastic using epoxy or anything else like that.
I haven't had that, but I know that's something you have to worry about because sometimes some chemicals interact in a bad way. So, okay, let's keep on moving. Finally, PETG. This is what's underneath here. The fingers on this suit I made in PETG so that I have like an extension to the fingers because the character is a little bit long. He's got big and he has giant hands, right? I didn't want to use PLA because it was a little bit too weak for what I was going to be doing. So I built it out of PETG with TPU fingertips. So these are little things that I found a model for on like Thingiverse. And then I re-engineered it so that I could have like hands built out of this. And this is PETG material. It's really strong. They've held up really well. Given I've taken them to do cons, I've high-fived people, I pick up things. And then I just engineered it to have little pieces that lock into each other so that I could add the fingertips being made out of TPU so that they're squishier and softer. It's not as aggressive if I like do tap people with it. But it's really simple. Like it's one of the things that like, you know, I find a model on a website, I send them $5 or whatever, and I then have something to play with that allows me to do something that I otherwise would have had a hard time doing, or it could have taken me a long time to engineer. But yeah, it's kind of a cool, like, this is what I would use PETG for. It's something that, like, it's going to have a lot of wear and tear. There's a lot of work that goes into it, and I want it to last as long as possible. So this is where I would use that material. Anything that's going to be a little bit more structural. If I was going to make, like, a fursuit beak or something like that, where I knew that it might, especially like a moving jaw kind of thing, I would probably go with leaning into PETG. And PETG is still, like, there's ABS and some other filaments that you have to worry about ventilation with. PETG is still relatively safe as far as filaments go. So it's a really cool piece of something you can do with technology there. So next up, I'm going to talk briefly about like patterning and technology. This is the suit that I was showing you here. I tried to use a mixed method of building it. You can see the top half is all foam sculpted. And actually how I did that is I 3D modeled, I took a scan of myself, I 3D modeled the body shapes over the top of it. I printed it in 1/6 scale and then made a tiny little tape pattern out of that. Scanned it with my cheap computer scanner and then used a projector, just like a cheap projector on a wall, and then scaled it up. And then I was able to build that shape from a little guy this big. Like he lives in my room now, and whenever I need to make new models or something, I could just build it at scale. The old method of doing this, when I used to make fursuits, or more traditionally, it was I would take a duct tape dummy and I'd hang all this stuff off of it. I'd carve a bunch of foam. I'd have to throw a lot of stuff away, and it was just super wasteful process. This is so easy to do and like remarkably simple. And you use contact cement and foam, and you can make a lot of stuff that way. And you can see on the left, right there, the entire lower body is 3D printed. So the haunches, the thighs, the calves, the feet are all 3D printed. And he walks and moves around really easily. It's super lightweight. It's nice to wear. One of the advantages of having this like open cell 3D print is that you get it breathes. It breathes super well. Like these are just open. You can feel the air go through it when you're walking around, as opposed to like polyfill where it's a lot more stuffy. It gets a lot hotter. So I've been loving using this, and I'm trying to find more ways to use it in my own projects before I start giving it to other people. There's a artist, Kazul, does Kazplay on YouTube, has a bunch of tutorials on how to do things in scale. I really recommend looking at her stuff because she's incredibly talented, and has a bunch of tutorials on how to get started and that kind of stuff. Yeah, who is it? Kazul, Kazplay, so they really go by probably like YouTube and stuff. And then there's a couple of things you can do. Cozy Blanket is an application on the iPad that allows you to like UV unwrap, which is basically how you color a model in 3D for like if you're going to use like a VR chat avatar, you have to make a UV unwrap, which is basically how you turn a JPEG into a person, right? It just stitches things together in a way. But you can actually use Cozy Blanket has a papercraft mode that you can use to create patterns from. So you can literally take a model in 3D and unwrap it and make it into pattern pieces. So dye sublimation is another technology, a side technology that I think is really cool. Basically taking a print and ironing the dye into a material. It uses heat to transfer. You have to use specialized paper and specialized ink. And you can lay it on top of something and use heat to transfer that into the material. And that works on fabrics, but also plastics as well. You can do minky fabric as well. I'm going to pass these around. These are unused blanks. These are dye sublimated blanks. These are just white pieces of plastic that's actually, it's PC case fan venting material. It's just basically to cover your fan vents on your PC. And then from that, I dye the back black using a dye sublimation black sheet. You put a heat press on top of it for 40 seconds. It permanently makes it in there. You can scratch these and feel like it's not coming out. It's impregnated into the material. And the front is just printed. I did that in Photoshop and a couple other apps. You can just use any art app and create the colors. So you can see this one was a failed one where I just didn't have it going as long, and you can see the imperfections in there. But these ones were good. I just tend to like, if I'm going to use a piece of paper to print it, I'm going to use the whole paper and make a few different versions and play around with saturations until I see the one I like the most. So you can pass this around. But that's dye sublimation. Super approachable nowadays. Epson sells printers that you can change your own ink on now, that you just use third-party ink and you pop it in there and set up some dye sublimation settings. And you can see it there. I use it for a fursuit tag for a plush suit. This little silk, pretty little silk tag. And it's permanent. It's on there. It's part of the thing. So I'm going to do this one last thing, and then I'll ask any questions because we're getting close to time. The last thing I want to talk about is electronics. I'm not going to have any time to talk deep about this, but there's so many resources now about integrating electronics into props, and they also work for fursuit stuff. One of my favorite sites is Adafruit. They sell everything you need. Everything you need. Lights, the Arduinos, the modules that allow you to connect to Bluetooth. There are tutorials after tutorial after tutorial that with a little modification you can make things happen. So like that mask there was something that my friend programmed for me. But I just put in some wires that were programmed in with certain code, and we were able to get this. And this is, the ears are resin printed, the mouth is resin printed, so it's translucent, and then the rest of the face was that Kazplay. And then I sanded it, smoothed it, and then gilded it, gold leaf on there and everything. And it's super approachable. These ears on this guy are actually also they have servos in there. This is actually a third-party software called MyTail. It's a company that makes ears and things like that. Let me see if I can get them working here. There it goes. So yeah, something like that. You can pretty easily. I rewired them. I took it apart and rewired it so that the box controlling it, which is in my hand here, is not attached to the head, just because I wanted the electronics away from my sweaty face. But it's really cool what you can do, and this software that they give with it for free is just super easy to program. Simple things. You can do things if you detect I'm walking or I tilt my head in a certain way, automatically do this. So pretty smart stuff. But then programming yourself is also a totally viable option, and it's kind of amazing that there are so many options available as far as this kind of stuff goes. It's kind of like the area that I want to explore most. I have a couple of cosplays I want to do in the next year that require a lot more work than this, but this was kind of my gateway into getting into that kind of stuff. So, yeah. Other than that, I think that covers it as far as what I wanted to talk about. We've got a few more minutes if people have questions. I'll just kind of start here and work my way over. So yeah, go ahead.
What kind of nozzle do you use with auto stuff for work?
I use a 0.4 nozzle. Yeah, it's my go-to. It's a good size, but it has a good amount of extrusion. Nothing I do needs anything finer, but I have a 0.6 and a 0.8. But I haven't really needed to go into that yet, though I really think it'd be fun to use the big nozzle just to see if I can do something super fast. But yeah, it's been my go-to. I've actually had the same nozzle on that machine for like 5,000 hours of printing, and I never needed to replace it. So yeah, it's crazy. It still works just as good as it did the day that I bought it. It's amazing. So yeah,
Would you recommend using a FreeCAD for the FreeCAD stuff?
I haven't used any in FreeCAD, or I haven't. I'm not familiar with the software, but there's like so much out there that I think is probably pretty good, and there's more people just making that software. So I can't say one way or another, but I'm all for trying out new things because I'll regularly do new trials of stuff and see if I like it. If it works, then cool. If it doesn't, my go-to is Shaper 3D right now. It's a paid service, but being like an engineering background, it's really fun to play with having like that kind of level. It kind of reminds me of Google SketchUp when it first came out. Super fast to use, like super intuitive, and I love that in the iPad format. So, yeah. Go ahead.
What? Okay. So the electronics for the ears and stuff. What type of board are you using? Like a Raspberry Pi, or is it an Arduino?
This one just has it. This one came with it. It's got a little. I think it's a little Arduino in there, but it's inside here. It's a little tiny guy. I've used a couple of the Adafruit's Arduinos before for various things. I think the guy that lit up has the Arduino in it, and I think I just like got a bunch of kits to play with, and I used the first one that I found, and it worked because it was small enough that I didn't have to run much code for it. But I didn't know that it was running into its limits as far as what it could use, because I was a mini, just a little tiny guy that didn't have much memory to it. So.
Right. Okay.
But yeah, that's an area that I want to play with more because it's not the strongest area for me, but it's more approachable now than it's ever been. There's so many tutorials and people making cool stuff. So yeah.
If you did have to take one printer, knowing what you know now, what would you use? If you had to only print.
So I would probably pick. Thank you. I would probably pick. So if I had to buy just one printer right now, it would be the Prusa XL. It is a good happy medium between its size and its speed. And the multiple head printing, I only think I need 2 heads. It does up to 5. The multiple head switching and not having to, especially for PLA printing, which is what I do mostly with that, it's been a dream. And it tends to do PETG better than the other one as well.
Yeah, I've been thinking about getting an upgrade recently.
Yeah, I love that. That is like my favorite. The XL is like so fast. I'll turn my head and the print will be done. It's just incredibly fast. So yeah. Anybody else? Yeah.
When you're doing 3D scanning, are you rotating the object or are you rotating the camera around it?
The ideal is rotating the object. With people-sized stuff, you gotta rotate the camera. The Revo point that I have, you can put registration dots on things. It's just a little reflective sticker, and that can be really helpful for helping it find itself again. But people are really difficult, and it's a pain in the butt to try to do something that's organic in shape because you blink and it sees that, and now it doesn't know where it is anymore. Because it uses points that in space to help it figure it out. But yeah, okay, cool. All right, well, we are out of time, I think, here. So yeah, it's 3:30, so I gotta cut you off. If you have any more questions, we can talk outside. But thank you all for coming. I'm going to try to take the various footage that I took and put it up on YouTube. So
What YouTube channel?
It is the Fuzz Factory on YouTube. So thank you all for coming.